Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. I am Ahmed Mumtaz Mustahsan, your teacher for CSC 141 Introduction to Computer Programming. Students, today we will start another topic which is a very important topic in C language. It is the power of C language, which is called pointers. I picked up some reference material for which I have acknowledged, and the lot of information is available. So I picked up some very interesting examples and the different text exercises which I consider more appropriate for this particular lecture. So our topic is pointers. What is a pointer? Pointer is a variable that contains memory address as its value. Okay. The variable, what is variable? Variable is the name of the memory location that contains the data. So a variable name directly reference a value. You whenever use a particular variable, so in the output statement or in the assignment statement or anywhere in the program, you use the variable name and you pick up the value whatever you have stored in the variable. Whereas a pointer indirectly reference a value. Referring a value through a pointer is called indirection. Okay, instead of directly pointing to a particular data elements, you have got the address of that memory location and you use that memory address to pick up the data. So it is not direct, rather it is called indirect. And referring the data value with the pointer is called indirection. Just like the variables, it is mandatory that you must declare the pointer. You must declare the pointer in the beginning before using it. Whatever you use in C language, whether it's a variable name, whether it's a function, whether it's a pointer, or whether there are few more things that you will be using in future, but we are bound to declare it in the beginning. So let us quickly go through the concept of address of pointers. Memory can be conceptualized as a linear data locations, set of data locations, and they directly contains the contents, and these are the corresponding address, right? Address 1 for this particular memory location, address 2, address 3. This is basically the array, and this is the corresponding address of each and every memory location. The content of a pointer is not the data. The content of a pointer is the address. Students, this is very important concept. Please try your best to understand this concept, that a variable name or a variable in short contains the contents, contains the data, whereas a pointer does not contain the data. A pointer contains the address of the memory location where you have stored the data. This is most important concept that you should understand. So how can we declare a pointer? We can use an asterisk when we use to declare the pointer. When we are required to declare a pointer, we use static here. So we, instead of saying integer aptr, integer a pointer, so if it is a pointer, then we say int static aptr. What does it mean? It's mean aptr is a pointer to an integer data type, a pointer to integer. Similarly, float static bptr is a pointer, bptr is a pointer to float data type. cptr is a pointer to a character data type. So we can say that we can use a pointer after declaring the pointer, and each and every pointer must specify that which data type it is declared for, or which corresponding data type it is going to refer. Either it's a pointer to integer, or pointer to float, pointer to double, or pointer to character. Let us see how we are going to use it in our program. So this is a standard program starting. So declare a pointer to an integer. वही जो पिछली slide में मैंने आपको बताया, same we are using here. Then float bptr, declare a pointer to a float. Integer a, is it a pointer? No, it's not a pointer. Why? It doesn't contain static here. So the difference between int aptr and int a is that it contains the static, whereas it does not contain any static. Float static bptr is a pointer to a float, and float b is a variable which has a data type float. Then aptr is equal to a %sign a. What does this %sign do? We have already used it. Where? In this scanf function we have used %sign, and इसका purpose क्या था? In order to pick up the address of that particular variable, we use %sign before the variable name. Up here the variable name is a, so in order to pick up the address of this memory location, we use this %sign. This %a returns the address, means that it loads the address of int into a pointer aptr. ये % से लोड नहीं होता, बल्कि % जो है रिटर्न करता है एड्रेस ऑफ द मेमोरी लोकेशन. ये असाइनमेंट ऑपरेटर, this address which is returned with the help of this %sign is assigned to aptr. Similarly, we can load the address of the b pointer, that is the address of the float variable b into bptr. Okay, in this way we have declared the pointers, and here we have loaded the address of the pointer. So what is % is used for? I have just explained it to you that % is an address operator which gives or produces the memory address of the data variable. किसी भी variable से पहले, just before the start of the name of the variable, if you put %sign, it will provide you the address of that particular variable. So with the help of this %sign, we can use or we can reach to the address of that particular variable name. So then what is this static is used? Dereferencing operator. इसके दो यूज है. एक यूज तो हमने देखा at the time of the declaration of the variable कि हम data type के बाद static use करते हैं, then we use any variable name. It's mean that we have declared a pointer, and then in the program whenever we use static, it's mean that we are not interested in the contents, rather we are interested in indirection. What does it mean? कि हमें जो जिस पर्टिकुलर वेरिएबल से पहले हम स्टैटिक यूज कर रहे हैं उसके कंटेंट्स पे इंटरेस्ट नहीं है, बल्कि उस कंटेंट को वी शुड बी यूजिंग इट एज एन एड्रेस एंड देन गो टू दैट पर्टिकुलर एड्रेस एंड पिक अप द कंटेंट्स. So this is indirection, and this indirection is achieved with the help of this static, okay, which provides the content in the memory location specified by a pointer. Okay, समझ में आया? तो हमने इसके यूजेस देखे static के. One at the time of the declaration of pointer, second at the time of showing the system or telling the system that we are interested in indirection, not with the variable name. Let's talk about the memory addresses. Computer has got a consecutive memory locations. This consecutive memory location or storage cells are typically viewed as बाइट साइज्ड. हम नॉर्मली बाइट्स की टर्म में बात करते हैं, चाहे हम गीगाबाइट्स की बात करें, चाहे हम टेराबाइट्स की बात करें, चाहे मेगाबाइट्स की बात करें. सो बेसिकली वी रेफर द मेमोरी विद द यूनिट बाइट्स. So the smallest addressable unit of the memory is usually byte. There are some machines that allow you even to address or even to reach to the bits level also. Such addresses are sometimes called byte addresses. But in order to have a very quick address of the memory location, we don't use byte addresses. So memory is often accessed as words. So every computer has got its word size. It could be 16-bit, it could be 32-bit, or it could be 64-bit. 16-bit is now almost obsolete. Basically we have 32-bit word size and 64-bit person. Most of the machines which are presently available, although are 64-bit, but we prefer to use them in the form of 32-bit. तो मैं आपको later on कभी मौका मिला तो I will just give you some more detail कि we have got an operating system which is a 32-bit operating system or the operating system which is a 64-bit operating system. ये क्या है? 32-bit operating system or 64-bit operating system is basically the capability of the system to access the memory location and to manipulate the data. If your system is capable of manipulating 32-bit at a time, then it is a 32-bit machine. But if your computer is capable of handling 64-bit data, आप memory को reference भी 64-bit से कर सकते हैं, then not only the reference but after that you can manipulate the 64-bit data. उसका computer का जो architecture है, if it allows you to manipulate 64-bit of data, then we call कि ये machine जो है वो 64-bit machine है. A word size may be 4 or 8 bytes. वही बात है जो मैंने आपको बताई. 4 बाइट का मतलब है 32-bit और 8 बाइट का मतलब है 64-bit. Why? क्योंकि there are 8 bits in 1 byte. We can check the use कि आपकी मशीन जो है वो किस वक्त जो यूज कर रहे हैं उसका ऑपरेटिंग सिस्टम जो है वो किस पर कॉन्फ़िगर हुआ है, आपने कौन सा इंस्टॉल किया हुआ है. So what you can do, you can use a facility in C language which is called Sizeof. So you can find out the size of long. Long is basically the long integer which normally is equal to your word size. So it will return, if it returns 4, it is 32-bit. If it returns 8, it is 64-bit. A word address is simply the byte address of the word of the first byte. Do you remember? कि जो हमने बताया था कि array का जो address होता है, that is the address of the first byte. The first element, sorry, the array का जो address होता है, it is the address of the first element of the array. इसी तरीके से जो word address होता है, it is the address of the first byte of the array. So if we say that the machine is of 4 byte 32-bit machine, तो 4 bytes के अंदर कोई तो एक byte होगी which is the first one. For example, 100 से start हो रही है तो 100, 101, 102, 103. So 100 और 103 में से which one should be the address of that particular word? जो first byte है, that is considered as the address of even that particular word. एक तो word है ना, that contains the address of anything. But word का जो अपना address है, that address whichever is printed or depicted is basically the address of the first element. Coming back to the pointers once again, special cases of bounded size natural numbers. What does it mean? Maximum memory is limited by processor word size. अब आपका जो word size है, that contains the address. अब उसमें जो बड़े से बड़ा एड्रेस उसमें फिट इन होगा, that is the capability of your machine to access the memory. If your system is 32-bit architect, then the maximum address is 2 raised to power 32, or normally 2 raised to power 32 minus 1 because you start from 0. So basically the range is 2 raised to power 32 is 4 gigabyte. 4 gigabyte. But if your machine is of 64-bit machine, then it has the capability to access 2 raised to power 64 is equal to 16 exabyte. आपने शायद ये टर्म कम सुनी होगी. So basically we have 1 kilobyte which is equal to 1 megabyte. यानी कि 1 megabyte is equal to 1000 kilobytes. Similarly, 1000 megabyte is equal to 1 gigabyte. Exact 1000 नहीं होता, it is basically 2 raised to the power 10. So 2 raised to the power 10 is 1024. It's not exact 1000, it is 1024 because we talk about in the terms of binary number, and 2 raised to the power 10 in binary is not 1000, it is 1024. So हम generally k की जब बात करते हैं तो 1000 कहते हैं, but basically it is 1024. So then 1024 gigabyte is equal to 1 petabyte. Then 1024 petabyte is equal to 1 hexabyte. Okay, so we have a gigabyte, gigabyte के बाद we have got terabyte, terabyte के बाद we have petabyte, and petabyte के बाद we have exabyte. I think I skipped terabyte. So 1024 gigabyte is equal to 1 terabyte, and 1024 terabyte is equal to 1 petabyte, and 1024 petabyte is equal to 1 exabyte. ये just a concept है, so I just thought के I should explain it. A pointer is just another kind of value. Another kind of value. What does it mean? It is just like another variable. We can treat it like variable, but it has got a very special usage. So if we use it with the help of static, we can use it as a pointer. So the variable PTR is a pointer to an integer, जैसे मैंने भी पिछली एग्जाम्पल में भी आपको बताया. Before I just continue with the pointer, I have used a terminology, a keyword size of. So just to give you an example, if you want to see that how can you find out the size of your machine, so you can use the term size of int, yeah, size of long. That should return 2 if it is a 16-bit, but there are hardly 16-bit machines, so it should return 4. Or if it is a 64-bit machine, then it should return 8. Size of array. So size of जो है वो सिर्फ आप डेटा टाइप के लिए नहीं बल्कि किसी भी defined data type के लिए. If you have defined an array as a data type, you are using it, then it will return a value 80. What does it mean? It will return the number of elements of a particular array. So size of double, you will return 8. So if this is the array and that contains 10 elements, then the size of the array is 10 multiplied by 8 is equal to 80. Okay, so that is the size of the array. Coming back to the pointers. How to pick up the address of the variable? We have already talked about it, that we can pick up the address of the variable simply using the ampersand sign. If you use ampersand sign, variable address can be picked up. It returns the variable memory address. How to pick up the content of the address loaded into the pointer? We can put static before the pointer variable. If we use static pointer, it will not return the content of that particular variable, which is pointer variable. Rather, it will return the content stored at the address. So this is indirection. Then indirect assignment. Can we assign a value also? अगर हम इससे कंटेंट पिक कर सकते हैं तो क्या हम इसको कंटेंट असाइन भी कर सकते हैं? Yes, we can do that, and we can use just like that. Static PTR is equal to value, whatever value, whether it's a constant, whether it's a variable, whatever, you can use it just like an ordinary variable because you have used an indirection here. So now you have an indirect access to that particular content, so you can assign the content values here. So it also allows to use without static pointer. Now you have to be very careful. If you are using it without static, what does it mean? It means that you are using it like an ordinary variable. In that particular case, you must be careful regarding the matching of the data. In that case, you can only assign the content of one pointer to the other pointer. We are not using ampersand sign here to pick up the address of PTR to load it into the pointer. Why? Because PTR has been declared supposingly as a pointer. And if PTR has been declared as a pointer, then the PTR should contain the address. We can directly copy the address from one pointer to other pointer. हाँ, जब उसके contents आपने यूज करने, फर्ज किया कि PTR के pointer to the data type static PTR अगर आप यूज करेंगे, then you must use static here to pick up the content, and you also use in order to copy the content of one pointer type to other pointer. ठीक है, अगर आप एक x is equal to y करना चाह रहे हैं and with the help of pointer करना चाह रहे हैं, तो आप करेंगे pointer to x static pointer to x is equal to static pointer to y, or vice versa. Now I show you one example. In this particular example, we have declared integer I1, this is a variable, integer I2, simple variable, pointer to an integer, PTR1 is a pointer to integer, PTR2 is a pointer to integer. Now PTR1 and PTR2 are pointer to integer 1, a pointer to integers, whereas I1 and I2 are two integer variables. We initialize I1 is equal to 1 and I2 is equal to 2. Then we say that PTR1 is equal to address of I1. यहाँ क्या कर रहे हैं कि we are picking up the address. So I just show you how it will work. First of all, we use this statement. I1 is equal to 1. What happens? Students, देखिए, this is I1. When I said I1 is equal to 1, the content of this memory location is loaded is equal to a simple ordinary use of the variable. Now I say I2 is equal to 2, this 2 is here, simple ordinary variable is loaded here. Next, pointer address is address of I1. What will happen here? Look, समझ में आया what happened? Address of I1, इस variable का जो address है is this address 1000. Okay, this is an address which is in octal. Okay, and this address is has loaded into a variable pointer PTR1. यहाँ समझने की कोशिश कीजिए कि this is 4 bytes, these are other 4 bytes. So this example is using an address of 64 bit, 8 byte का address use कर रहे हैं. लिहाजा ये जो pointer की bytes हैं, these are the higher bytes, these are the lower bits and these are the higher bits. आप assume करें कि ये दोनों जो हैं they are placed consecutively. So this address is loaded into the lower 32 bit. Okay, इसको lower 32 bit में, because the smaller address, so it doesn't come up here. So the upper 32 bits are empty. In the lower 32 bit में the address has been loaded. What has happened? Pointer 1 this has been loaded with the address of variable 1. ये address of variable 1 has been loaded. अब हम pointer 2 के अंदर pointer 2 में load करेंगे address of pointer 1. We have done that. This address pointer 1 का जो address है, which is also is here, this address has been loaded into, वही बात है इसकी lower 32 bit के अंदर, this is the 32 bit pointer. So this part and this part is indicating pointer 2, this and this is, that's why यहाँ पे dot 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 है, means कि ये pointer 1 का lower part है और ये pointer 2 का lower part है. The PTR2 is equal to this one. यहाँ पे हमने address load किया था, अब हमने पॉइंटर टू पॉइंटर कॉपी किया है एड्रेस, इसलिए हमने एम्परसेंड साइन यहाँ पर यूज नहीं किया. दिस इज मोस्ट इंपॉर्टेंट कॉन्सेप्ट. व्हेन वी पिक अप द एड्रेस ऑफ अ वेरिएबल we use ampersand sign. When we pick up the address from one pointer to other pointer, we don't use the ampersand sign. This is most important. You must remember that. Okay, let's see what happens here. What we are doing, we are interested to put the content of pointer 1, means whatever memory location pointer 1 is showing, and pointer 1 is basically having the address of variable 1. So this ptr1, static ptr1 is here. So means के इस जगह पर हम 3 प्लेस करना चाहते हैं. Okay, content pointer to integer, pointer 1 to integer, which is basically variable 1, is equal to 3. Now I2 is equal to content of pointer 2. Pointer 2 also contains the same address. Therefore, हम variable में इसके contents को जब copy करेंगे, 3 should be copied here also. 3 is copied here also. Okay, so this is the most important concepts, and with the help of the memory location, I have tried to demonstrate it. So let us see some confused statements that may confuse you. It will not never ever confuse compiler or the system, but it may confuse you. कैसे? Suppose we have defined a variable int1 and int2, which are integer variables. This is 1036 and this is 8. Then we have declared int pointer 1 is a pointer to an integer and int pointer 2 is a pointer to an integer. We have declared 2 variables, integer variables, and we have declared 2 integer pointers. Okay, now what we are going to do here, we are trying to, this is integer pointer 2. Integer pointer 2 is supposing we this, and what is this? This is the, yes, this is a pointer. We are trying to put the content of a pointer to an integer pointer, and this is pointer to an integer. So what we are trying to do, हम एक address को इस integer के अंदर load करने की कोशिश कर रहे हैं. और इस statement में क्या है? इस statement में हम simply integer 2 के जो contents हैं उसको integer 1 के contents में डालना चाह रहे हैं through the pointer. So let us see what happens. Type checking warning. Integer point 2 is not an integer. Integer pointer 2 is not an integer. It's a pointer to an integer. It is not an integer. So अगर integer का size है 4 bytes 32 bit, तो pointer का size अभी आपने देखा था कितना था? Pointer का size जो था वो 64 बिट्स था. तो 64 बिट का डेटा 32 बिट के अंदर आप कैसे लोड कर सकते हैं? यू कैन नॉट लोड द एड्रेस ऑफ ए पॉइंटर इनटू द इंटीजर डेटा टाइप. सो ये आपको यहाँ पे वार्निंग देगा, टाइप चेकिंग वार्निंग, इंटीजर पॉइंटर 2 इज नॉट एन इंटीजर. एट द टाइम ऑफ कंपाइलेशन यू विल गेट दिस वार्निंग. एंड व्हाट विल हैपन हियर? int1 becomes 8. कैसे? कि आपने इंटीजर 2 जो कि 8 था इसको आपने इनिशियलाइज कर दिया पॉइंटर थ्रू इंटीजर पॉइंटर 1 विच इज पॉइंटिंग टू दिस मेमोरी लोकेशन. सो इंटीजर 1 को पॉइंट आउट कर रहा है बिकॉज वी हैव लोडेड द एड्रेस. वी सेट द स्टैटिक इंटीजर पॉइंटर 1 विच इज इक्वल टू int 2. So if it is having the address of pointer 1 that we have done it here, it is we have loaded the address of this integer into this integer pointer, and integer 2 को हमने लोड किया integer pointer 2 में और integer pointer 1 में हमने integer 1 को लोड किया. So हमने इसके contents को 2 को 1 में इस तरह डाला कि we have used this pointer to an integer. Okay, let's see 2 more statements here. Once again the same example, but this time what we want to do here. Here we say integer pointer 1 is equal to static integer pointer 2. What we are doing? Once again we have mismatch here. We are, इसका मतलब है static का contents. We are putting the integer contents into the integer pointer. हम पॉइंटर में जिसमें कि एड्रेस होता है उसमें इंटीजर कंटेंट्स लोड करने की कोशिश कर रहे हैं, और हेयर वी आर कॉपिंग द एड्रेस ऑफ इंटीजर पॉइंटर 2 into the address of integer pointer 1. So what will happen? Type checking warning. Static integer pointer 2 is not an integer pointer. This is not an integer pointer जिसको आप इसमें कॉपी कर रहे हैं. But here integer pointer 1 does not change int 1. Here it will not give you any error message. आपने क्या किया कि pointer 2 का एड्रेस जो है वो pointer 1 में डाल दिया. इसका मतलब ये नहीं है कि इंटीजर 1 के कंटेंट्स ऑटोमेटिकली चेंज हो गए. पॉइंटर 1 वाज जस्ट पॉइंटिंग आउट टू दिस मेमोरी लोकेशन व्हिच कंटेन दिस वन. स्टिल इंटीजर 1 विल कंटेन 1036. हमने क्या किया कि इसका जो पॉइंटर यहाँ पे हमने लोड किया था उसको हमने ओवर दोबारा रीलोड कर दिया. अब पॉइंटर 1 जो है वो भी पॉइंट आउट कर रहा है इंटीजर पॉइंटर 2 को, और इंटीजर पॉइंटर 2 जो है वो तो पहले ही इंटीजर पॉइंटर 2 को लोड कर रहा है, शो कर रहा है. ओके, देयर इज ऑल्सो अ स्पेशल पॉइंटर which is called special const pointer which is null. Okay, so we can dereferencing illegal causes a segment value. If you want to check a null pointer, we can only, if you want to check any contents of any pointer, you can check it with a null pointer only. Okay, otherwise you cannot check that. But if you will use this null pointer, it should give you a segmentation fault, क्योंकि null address is basically the zero address, or zero address you are not supposed to access zero address because it is the address which is restricted, which is used by the operating system. Therefore it will give you a segmentation fault कि आप ऐसे segment में जाने की कोशिश कर रहे हैं मेमोरी के where you are not supposed to go. Let us see how can we perform arithmetic and logic operations on the pointers. Just like variables, a pointer may be incremented or may be decremented, but we have to be very careful. What do we do with the pointer when we increment it or decrement it? An integer may be added to or subtracted from a pointer. अगर हम increment कर सकते हैं, one add और one subtract कर सकते हैं, तो we can add any other number and we can subtract any other number from the contents of the pointer. A pointer variable may be subtracted from one another. आप ये भी कर सकते हैं कि pointers के अंदर आप कह सकते हैं static ptr minus n. This n may be 1, may be 2, may be 3, or any value. So if you can subtract this, yes, you can subtract any variable that should contain, maybe logically or ideally it should be the integer variable. So with the help of the integer variable you can perform this addition and subtraction. Pointer variable can be used in comparison, but usually only in comparison to null. जो मैंने अभी पिछली स्लाइड में भी आपको बताया. आप सिर्फ ये चेक कर सकते हैं क्या किसी पर्टिकुलर पॉइंटर का डेटा नल है या नहीं. Otherwise it's usually not logical, but you can compare one contents of one pointer with the other pointer also. या तो आप कांस्टेंट चेक करते हैं जिसमें आप हमेशा नल चेक करते हैं, या आप एक पॉइंटर के कंटेंट्स को दूसरे पॉइंटर के कंटेंट के साथ कंपेयर कर सकते हैं. अरिथमेटिक ऑपरेशंस कंटिन्यूड. When an integer is added or subtracted from a pointer, a new pointer value is changed by the integer times the number of bytes in the data variable the pointer is pointing to. समझ में आया? नहीं समझ में आया? I'm sure. Difficult है. I will explain it with the help of examples. कि जब हम कोई subtract करते हैं या add करते हैं कोई integer value to a pointer, तो वो integer value directly add नहीं होता, बल्कि वो jump लगाता है towards the size of that data type. Okay? अभी भी नहीं समझ आया? Okay, I'll explain you with more examples. If the pointer val ptr contains the address of the double precision variable and that address is, suppose this is the address 234567870, then this statement if you add 2 तो क्या होना चाहिए? 70 की जगह पर 72 होना चाहिए, लेकिन यहाँ तो instead of 72 it is 86. So how much has been added? 16 bytes. We have added 2 bytes and it has added 16 bytes. So why added 16 bytes in the address? This is the topic that we are studying. अब हम ये देखते हैं कि क्यों 16 bytes ऐड हुई, 2 bytes क्यों नहीं ऐड हुई. For that purpose, we would like to see this particular example. So we have got a pointer plus a number, and here we have a pointer minus a number. When we add a pointer plus 1, add 1 something to a pointer. What's that? This is the example. This is pointer to a character. Character static P. This is pointer to character, character A, character B. Then we load address A, which is a character and character variable. Its address we have loaded into P. Then we said P plus is equal to 1. We have added 1 to the content of this pointer. Same thing we have done it here. We have declared P is a pointer to an integer. This is integer A, integer B. Then we have loaded the address of this variable to this pointer, and then we have added 1. यहाँ पे भी हमने ऐड किया 1, यहाँ पे भी हमने ऐड किया 1. What happens? Add 1 multiply by size of character to the memory address. Add 1 multiply by the size of the integer to the memory address. Here, since the character contains the size equal to 1, so it will add only 1 in the pointer. So whatever the address is, it will have added 1. Here, it will not add 1. You have added 1 means you have added 1 integer variable, the size of an integer variable, because the pointer is pointing to an integer, and suppose integer contains 4 bytes. So instead of adding 1, it should add 4 bytes. अब समझ में आया कि वो 16 क्यों ऐड हुआ था? So pointer arithmetic should be used very cautiously. Let's go back and see कि 16 क्यों ऐड हुआ था. This particular pointer was valid pointer is equal to this one. This was a pointer to a double. Since this was a pointer to a double, therefore when we added 2, the size of the double is 8. So it has added 2 elements, 2 double elements. एक का size 8 and the second का size 8. So instead of adding 2 here, 16 was added here. और यही लॉजिक हमने यहाँ पर देखी कि when we added 1 here, it will add 1 and it should add here 4. So we need to be very careful. But we'll do some more practice today. So let us see this example, whatever we have learned so far in terms of pointers. This is a function, swap function, that is carrying 2 arguments, pointer to integer A and pointer to integer B. This is the prototype declaration. वैसे the prototype declaration है, it's not mandatory to use A and B. We could have simply said integer static, comma integer static, but still we can provide the name of the variables also. No harm. Integer main, A is equal to 5, B is equal to 6, printf, we can print the value, and this A is equal to 5 and B is equal to 6 will be the result of this print statement. Then we call this function and passed on the address of A and address of B. This function is caused this activation of this function. Address of A will be loaded to pointer to an integer A and pointer to this B. B is a pointer to integer, A is a pointer to integer. By calling this statement from here, this address of variable A is loaded here and address of variable B is loaded there. Now we swap the two. वही जो हमने last lecture में हमने सीखा था. How can we swap that? We need a third variable which is called temp, and now here we can say temp is equal to static A, static A is equal to static B, and static B is equal to temp. वो 3 statement हमें चाहिए होती हैं. Temp is equal to A is equal to B, B is equal to temp. वो हमने किया. So data has been swapped. Then we printed the value A and B. Pointer to A should contain 6. If 5, 6 means A has got 6 and B has got 5. So they are swapped and then it is returned. void. No data has been returned, but the data has been swapped. So control comes back here again in the main program. Here we just reproduce this print statement, and when we reproduce this print statement, it prints a is equal to 6, b is equal to 5. That confirms that the data has been swapped while calling the swap function. And how we have swapped the data? We have swapped the data by making a call by reference. Call by reference means instead of sending the values, we have passed on the address of the variables. And when we pass on the address of the variable, this is called call by reference. And once we have got the address of the variable in the calling function, then we have got the liberty to access the original variables, actual variables, क्योंकि उसका address हमारे पास है. Once we have got the address of any variable into a function, what does it mean? Means you have got the access to that particular variable. तो मेन जिन वेरिएबल्स को एक्सेस कर रहा था, अब फंक्शन के अंदर आपके पास वो एड्रेस आ गया, आपने उस एड्रेस को एक मेमोरी में वेरिएबल में लोड कर दिया. मींस कि आप उस वेरिएबल की मदद से आप सेम लोकेशन को एक्सेस कर सकते हैं. जब आप सेम लोकेशन को एक्सेस करेंगे, व्हाट डज इट मीन? कि आप एक्चुअल वेरिएबल के जो कंटेंट्स हैं उन तक आपको रसाई हासिल हो गई. नाउ इफ यू अपडेट the contents, if you swap the contents, if you delete the content, whatever you will do it in the function, the calling function, which is the main function or other function, should bear the consequences for that, or should accept the, because क्योंकि वो फंक्शन ही है जिसने उसका एड्रेस आपको पास ऑन करके लिबर्टी दी थी कि वो आप एक्चुअल वेरिएबल के साथ प्ले कर सके और आप वो एक्चुअल वेरिएबल को आप अपडेट कर सके. सो इस above example को थोड़ा sum up करते हैं. Pointers can be used to pass the address of variables to the calling function, thus allowing the card function to alter the values stored there. ये बात मैंने भी आपको explain की. We looked earlier at the swap function that did not change the values stored in the main system because only the values were passed to the function. ये हमने पहले एक लेक्चर के अंदर सेम एग्जांपल यूज़ की थी जब हमने कॉल बाय वैल्यू यूज़ किया था. जब हम कॉल बाय वैल्यू यूज़ करते हैं तो एक्चुअल आर्गूमेंट्स जो है जो आप पास ऑन करते हैं वो फॉर्मल आर्गूमेंट्स के अंदर उसकी कॉपी रिसीव होती है, और कॉपी के अंदर आप जो कुछ भी चेंजेस करें वो एक्चुअल में चेंज नहीं होती. बट वेन एवर वी परफॉर्म कॉल बाय रेफरेंस तो हम एक्चुअल का एड्रेस पास ऑन कर देते हैं, एंड एनी अपडेट that you perform in the calling function that reflects that changes into the main function or the calling function where you have called it. If instead of passing the values of the variable to the card function, we pass the address so that the card function can change the values stored in the calling routine. This is known as call by reference. ओके मैंने कोशिश की है कि मुख्तलिफ तरीके से आपको एक ही बात को रिपीट करके समझाने की कोशिश करूं. सो दिस इज कॉल्ड रेफरेंसिंग ऑफ वेरिएबल. दिस इज कॉल्ड रेफरेंसिंग ऑफ वेरिएबल. और स्वैप की एग्जांपल जो है जो हमने पहले यूज़ की थी, दिस इज call by reference, example of call by reference. This is the same example that I have discussed it in few slides back. Okay. Students, we have learned something about pointers. We have also learned a lot of concepts of the arrays. Let us mix and match these two. जो कॉन्सेप्ट्स हमने अरेज के लर्न किए हैं और जो कॉन्सेप्ट्स हमने पॉइंटर्स के लर्न किए हैं, हम उनको आपस में मिक्स एंड मैच करने की कोशिश करते हैं और देखते हैं कि इन दोनों को कंबाइन करके व्हाट वी कैन अचीव. सो व्हाटएवर वी हैव लर्नड इन pointers and whatever we have learned in arrays, we will try to mix and match both concepts. Quickly, just to pass it on, when we declare an array, an element of the same type, homogeneous data types of 10 elements are declared here, and this is integer array of 10. That means it is homogeneous 10 data elements. So array of 0 is the first element and array of 9 is the last element. Should we have array of 10 and array of -1? No. Why? When we declare an array from of size 10, it should range from 0 to 9, but no bounds checking, so allowed usually cause no error, but it will override the data. It will override the data. For example, int array of 10. So 9 के बाद we have declared an integer b. So when we use array of 10 is equal to 5, this 5 will be overwritten into this memory location. So basically array of 10 may override this integer b. So you need to be very conscious about that. Okay. What does this homogeneous means? Each element has the same size. We just need to understand this concept. Suppose an array of m data values in this sequence of m cross s bytes. आपने m elements declare किए. Each element of size s bytes. S bytes means integer है तो 4 bytes, float है तो 4 bytes, double है तो 8 bytes, character है तो 1 byte. So we assume that each data type has got s bytes and there are m elements. So how many memory locations we have reserved? M multiplied by s. These are the memory locations, m multiplied by s. So here the size is 4, number of elements are 3, so we have reserved 12 bytes. 0 से 8 तक we have got 12 bytes reserved because the size of 1 byte is this one. So m cross s means this one. So indexing 0th value at the byte, s cross 0 is the first value of the byte, s cross 1 is the second value, s cross this is the first value, this is second value, and this is, और इसको मल्टीप्लाई किससे कर रहे हैं? साइज से. So 4 multiplied by 1 is first byte, 4 multiplied by 2 is the second. और ये कौन सा होगा एक्चुअली? 0 के ऊपर फर्स्ट एलिमेंट, फर्स्ट के ऊपर सेकंड और सेकंड के ऊपर थर्ड. So this is the equation which is performing that. So m is the number of elements and s is the size. Both are not part of representation here. Int a of 3. ना तो हमने बताया कि इसका जब हम इसको यूज कर रहे होंगे, here तो at the time of the declaration yes it is there, but at the time of we use it. So unlike in some other languages, s known by the compiler, जब आप डिक्लेयर करते हैं यहाँ पर तो कंपाइलर को पता होता है कि डेटा टाइप क्या है, तो व्हाट इज द वैल्यू ऑफ s. m often known by the compiler, if not must be saved by the programmer. ये m कहाँ से पता चलता है? m means total number of elements. So basically if you are interested in one particular index, one particular element, so at that time you are not interested in the total size of that element. So your interest is the start of the array and then the index. So start 0, start first, this start second. So with the help of this start you can find out the 0 element, the first element, the second element. Okay. So when we declare the variable mix and match, what happens? Character C1 is basically you have declared here of 1 byte. Then you have declared an array of 3 integers. So what will happen? We have avoided using these 3 bytes here because we want to have a memory location that is multiple of these 4 bytes here. So these 3 bytes are not optimized here, but maybe if you use optimizer or some other technique might then be used, but otherwise it is left alone, and then it has used 4 bytes, 4 bytes, 4 bytes, then character C2 is the next one, then integer I is here. Once again it is not this one. So could be optimized by making these adjustments and reducing padding. By default it is not done. By default it is the convenience of the system to pick up the data. So if you declare like this, start like this, so it will be declared like this. Okay. So when we say integer array of 10, what is the size of array of 3? It's a quiz. We have done it few minutes back by using the array of size 10 and integer, but here we are asking array 3. Basically we are asking for one element, the size of one element, on that means size of third element. So it will return the size of an object in the bytes. So object क्या है? Object is your integer data type, और each element of the array is an object, और उसका साइज क्या होगा? जो कि इंटीजर का साइज होगा, और यहाँ पे साइज क्या होना चाहिए? 4. So it should return 4 here. Size of array, what it should return here? Size of this array, this we have done before. So it is 40, means 10 multiplied by 4, 40. उस example में it was 80, because we assumed that the machine had 64-bit address. So by default machine has 8-byte integer data. But if the integer has by default 4 bytes integer data, then 4 byte multiplied by 10, it should return 40 here. Can we access arrays with the help of pointers? This is a very powerful feature in C language. Yes, we can do that. The name of the array is the address of the array. Address of the array is the address of the first element of the array. दो बातें मैंने आपको बताई. The name of the array is basically the address of the array. जिस तरह मैंने आपको बताया था कि वर्ड का जो एड्रेस है is the address of the first byte of the word. Similarly, when we say the address of the array, it is basically the address of the first byte of an array. Address of the first byte of an array. Okay? और name of the array, याद रखिएगा, it is the basically address of the array. So array pointer to an initial 0 element, जो उसका एड्रेस है, एड्रेस किसका? अरे का, और वो कहाँ पे है? उसके नाम में. तो नेम ऑफ द अरे basically points out to the address of the first element of the array. So we can access a of 0 is equal to, now what we are doing, static, want to pick up the content, and we are using the pointer because name of the array is the address, so we are using the address, plus we are using the offset, क्योंकि हम pointer arithmetic भी सीख चुके हैं, तो हम 0 ऐड करेंगे, it remains the address. So it should return what? It should return the address of the first element. I will show you in examples later on. Then a of I, this is the general, and you can say that static a of I. By mistake it is again a of I, it should be a of n. So it is 0, standard middle, and a of n should be equal to a plus n static. An array is passed to a function as a pointer, the array size is lost. This is something that I have already explained कि हम जब किसी array को pass on करते हैं as a function के, तो हमें उस array का address तो मिल जाता है because name of the array is the address of the array, लेकिन उसका size is lost. That's why we pass it on the number of elements also separately to our calling function, जैसे कि हमने एक दो examples में किया भी है use. So what will happen here? Suppose integer foo is a function that contains the, this is not the prototype, but this is the definition. Integer foo, this is the first, it is picking up the array as an receiving argument, and then unsigned integer size is the explicitly pass on the size. This is pointing out the sending the address of the array, so it should be received like this in the square brackets. Okay, it is optional. You may define the name of the array, or it will automatically pick up whatever the name you will use it up here. Then you can use and refer this particular array just like an ordinary variable. This function के अंदर you are using it like an ordinary variable. How can you pass this particular, when you call this function in the main, you have called this function in the main, so you say foo a comma 10. So you have passed this array by sending the name of the function. Name of this array is a, which is a constant, which is an address that points to that particular array, and then we pass on the size of the array separately, and then we call the function again. This time we pass the address of the array, which is B, and the size of the array. And these two, address of the array and number of elements, are received here. Address is received in array, and unsigned integer receive the size of the array in terms of the bytes, that in terms of the number of elements. So how can we use that? Suppose we have used this one, then we can use this array. What does this should print? This is size of the array. Be careful. In the previous example, when we passed on the size of an array, so system returned the total size of an array. Yaad hai na, in the previous example? Let's quickly go back. Maybe I could just find it out here. This array, size of, where is that? Yes, here. Size of array, 40, size of array. What was that? 4 multiplied by total elements is 40. So should it be 40 here again? What does it should print? 40? No, it's not going to print 40, because it will just print 8, because array is really a pointer. Now this array is an address. So you have asked the size of function to provide you the size of that particular pointer. It is no more an array. You have passed it on. Basically you have passed the address of the array, and address of the array has been basically any address is picked up in a pointer. So address of any memory location is basically is the address, and if it is an address, then it is the word size, and if the word size is 64-bit, means it is equal to 8 byte. So it will not give you 40 or 80 here, it will give you 8, because array is considered as a pointer here, not actual array. What it should print here? Main program में size of a, वही चीज है ना, हमने इस a का size इसको pass on किया था array के अंदर, तो here it printed 8, but what it should print? Should it print 8 again here? It print 40. Is a mistake? No, it is not a mistake, because in the main program a of 10 is very well known. This array is very well known, containing 10 elements, and size of a means size of array a, whereas the size of array here means size of a pointer array. So size of a pointer is 8, whereas here, because this size is lost when you send the name of the array, it is the address of the array. That's why you have sent separately the number of elements. So this is very important concept that you need to remember. So these two blocks of code are functionally equivalent. We can use it here. I is equal to 0, I less than 10, increment I, and then you can use this array elements. Here what we have done, here we have declared I as a variable. Here we have declared integer static p. P is a pointer to an integer. P is a pointer to an integer. Now we have declared here integer array of 10, and what we do, the first part of the for loop is initialization, second part is test, third part is increment. So what will happen here? P is equal to array. Since P is equal to array, we have copied the address of the array into a pointer variable. This is pointer constant. Name of the array is the address of the array is a pointer constant. You cannot change the address of the array, or you cannot update the address of the array. So if you want to manipulate an array with the help of a pointer variable, you will copy the name of the array, which is a pointer constant, into a pointer variable. That's why we have copied array into P. Otherwise अगर हम यहाँ पे करते for initialization, skip, P is less than equal to array of 10, address of array of 10, and array plus plus, we cannot do that, because array is the address and this is a pointer constant. Although it also contains the address, but we have put it into the pointer, which is a pointer variable. So I have introduced a very important concept which is called pointer constant and pointer variable. Name of the array is the address of the array, which is a pointer constant. Whereas when we copy the address into a variable, it becomes the pointer variable. हम array के नाम को ऑटो इंक्रीमेंट नहीं कर सकते बिकॉज इट इज ए पॉइंटर कांस्टेंट, लेकिन जब हम इसको कॉपी कर लेते हैं वेरिएबल के अंदर तब हम इसको अपडेट कर सकते हैं. पॉइंटर अरिथमेटिक हम परफॉर्म कर सकते हैं, लेकिन डायरेक्ट किसी के नाम को, अरे के नाम को हम यूज नहीं कर सकते इंक्रीमेंट और डिक्रीमेंट करके. ओके, सो दिस इज द पॉइंट टू कॉन्सेंट्रेट. दिस इज अगेन एंड वी आर इंक्रीमेंटिंग इट. है तो वही ना, नेम ही है, बट सिंस वी हैव कॉपीड इट इनटू द वेरिएबल, पॉइंटर वेरिएबल, सो वी हैव टेस्टेड इट हियर एंड वी हैव इंक्रीमेंटेड इट एंड देन वी यूज इट. So we have used a variable to manipulate, pointer variable to manipulate an array. Okay students, sufficient concepts that we have discussed today in the lecture. No new concepts. Whatever I have taught you today or in the previous lecture, let us have a revision. And I have found a very good book. This is called Computer Science, a structured programming approach using C, and I have consulted chapter number 10, and I have picked up the material from the website of this book, and it contains very interesting revisions whatever I have taught you today and in the last lecture. So अब नए कॉन्सेप्ट नहीं बल्कि पुराने ही कॉन्सेप्ट को हम दोबारा से इस चैप्टर की मदद से रिवाइज करते हैं. The name of an array is a pointer constant to the first element. बड़ी मेहनत से मैंने ये बात आपको सिखाई. Name of the array is an address of the array which is constant, which is a pointer constant. And जो name of the array होता है that contains the address of the first element of the array. Because the array name is a pointer constant, its value cannot be changed. Since the array name is a pointer constant to the first element, the address of the first element and the name of the array both represent the same location in the memory. जो name of the array है वो ही उसके first element का name of the array जो है वो address of the array है, और एड्रेस ऑफ द अरे जो है वो एड्रेस है उसके फर्स्ट एलिमेंट का एड्रेस. सो नेम ऑफ द अरे इज इक्वल टू द एड्रेस ऑफ द अरे इक्वल टू एड्रेस ऑफ द फर्स्ट एलिमेंट ऑफ द अरे. ये रिवीजन है हमारी उस डेफिनेशन की जो हमने डिस्कस की. लेट अस सी विद द हेल्प ऑफ एग्जांपल. द नेम ऑफ एन अरे इज ए पॉइंटर कांस्टेंट टू द फर्स्ट एलिमेंट. ये है पॉइंटर कांस्टेंट. नेम ऑफ द अरे ए. It is pointing to the array A, and it is also pointing to the first element. Okay, so if I say A, or if I say address A of 0, this is the address of the array and this is the address of the first element of the array. मैंने आपको कहा था कि address of the array और उसके first element का address is same. So A is a pointer only to the first element, not the whole array. Okay, name of the array is the address of the array and it is the address of the first element of the array. और यही बात इस चैप्टर में बताई गई है. Name of the array is a pointer constant. It cannot be used as a value. आप pointer constant को किसी भी पॉइंटर कांस्टेंट आप वेरिएबल का हो या पॉइंटर कांस्टेंट आपने कहीं भी डिक्लेयर किया हो, ड्यूरिंग द एग्जीक्यूशन आप उसको चेंज नहीं कर सकते. और नेम ऑफ द अरे बाय डिफॉल्ट सिस्टम हैज कंसिडर्ड इट एज ए पॉइंटर कांस्टेंट, तो आप उसके ऊपर कोई भी पॉइंटर अरिथमेटिक नहीं अप्लाई कर सकते. सो दिस एलिमेंट इज कॉल्ड ए ऑफ 0 और 2. सो this is a very simple example. Integer a of 5, 2, 4, 6, 8, this one, printf %d. Now we are using it. This is a pointer constant that should contain the address of the first element, and a of 0, this should be first element of the array. So this will print 2 and this will also print 2. और ये क्या है? A of 0 is 2, और if we use it as, यहाँ पे हम इसको as a variable यूज कर रहे हैं, हम इसको चाहे A of 0 as a variable यूज करें या as a pointer यूज करें. Static A is the address of the first element of the array. A of 0 is the, you are referring to the first element of the array. ये आप वेरिएबल के तौर पे यूज कर रहे हैं या आप पॉइंटर के तौर पर यूज कर रहे हैं यहाँ पे, और दोनों सूरतों में यू आर पॉइंटिंग टू द फर्स्ट एलिमेंट ऑफ द array. ओके, अब हम क्योंकि a को तो चेंज कर ही नहीं सकते, why? A is the name of the array, A of 0, A of 1, A of 2, and it is a pointer constant, so we are bound to declare a pointer. हमने क्या किया? इंटीजर array है, now we have declared pointer to an integer and we have loaded the address into this pointer. Now although p is a pointer to an integer, but this is not pointer constant, although it contains the address a. आपने एड्रेस a जो है वो एक पॉइंटर के अंदर, विच इज ए पॉइंटर वेरिएबल, उसके अंदर आपने कॉपी कर दिया. अब नाउ यू कैन मैनिपुलेट विद दिस p. लेट्स डू दैट. व्हाटएवर वी हैव डन, सिर्फ मैंने इसको स्वैप किया है, रादर इस एग्जांपल में स्वैप हुआ है a of 0 एंड पॉइंटर p. पिछली एग्जांपल में देखें, पॉइंटर a, स्टैटिक a of 0, एंड इन द नेक्स्ट सिर्फ इसकी पोजीशन चेंज की है, अदरवाइज द सेम. a of 0 you are referring it as a variable, and pointer p you are referring the same variable but with the help of a pointer variable, because you have declared p as a pointer to an integer, और आपने इसके अंदर इसका एड्रेस भी लोड किया. What will happen next? Now this time we have loaded the, instead of loading the address of a here, we have loaded in this p the address of the first element. By default कौन सा होता है? 0. अब हमने first element का एड्रेस लोड किया है p के अंदर, and now we are going to print it here. %d a of 0 and p of -1. p of -1, be careful. a of 0 is 2, p contains the address of second element. Address of second element is this, that might be something, and we said -1. -1 means one previous element, so whatever the address it contains, it will subtract 4 because it is an integer, and it will have the same address of the previous element, so both will point out to the 0 elements. In the next statement, after new line, a of 1 and p of 0. a of 1 should print what? a of 1 should print 4 and p of 0 should print 2. It should be other way around. It should be, पहले इसको ये print करना है a of 1, and a of 1 is 4, so it should print 4 here, then it should print p of 0 and p of 0. Okay, we have loaded the address p of 1 here in p, and that should be the address of the first offset, so it should be 4 also. That's okay, that's okay. So the a of 1 is the address, it should be 4, and p of 0 should be 4, so it should be 4 and it should be 4, not 1. a of 0 is 2 and a of 1 is 4, so it should print 4 here because it is a pointer constant, और हम इसको as a variable के तौर पर यूज कर रहे हैं. Okay, you have noticed the difference? So to access an array, any pointer to the first element can be used instead of the name of that particular array. हम उस पे जो भी पॉइंटर के अंदर एड्रेस यूज करेंगे, हम उसको यूज कर सकते हैं wherever we want to start, and whenever from anywhere we can load the address into a variable, and we load it into the pointer. Any pointer to the first element can be used instead of the name of the array. So beside indexing, programmers use another powerful method of moving through an array with the help of pointers. और pointer variable के through हम move करते हैं, and we use the power of pointer arithmetic. अरे का एड्रेस पॉइंटर वेरिएबल में डाल देते हैं, एंड देन वी हैव गॉट ऑल द पावर ऑफ मैनिपुलेटिंग द पॉइंटर्स, एंड दैट वी डू विद द हेल्प ऑफ पॉइंटर अरिथमेटिक, जो हमने स्टडी किया. सो पॉइंटर अरिथमेटिक ऑफर्स अ रिस्ट्रिक्टेड सेट ऑफ अरिथमेटिक ऑपरेशंस फॉर मैनिपुलेटिंग द एड्रेस पॉइंटर्स. ये मैंने आपको पहले बताया कि जब हम पॉइंटर्स के साथ छेड़छाड़ करते हैं, एडिशन सब्ट्रैक्शन करते हैं, अरिथमेटिक करते हैं, इट इज नॉट द एग्जैक्ट नंबर दैट वी यूज, इट इज द नंबर ऑफ एलिमेंट्स. सो +1 का मतलब 1 नहीं होता, बल्कि 1 एलिमेंट फॉरवर्ड है. -1 का मतलब -1 नहीं है, बल्कि 1 एलिमेंट बैकवर्ड है. सो पॉइंटर अरिथमेटिक जो है, इट इज अ कंट्रोल्ड अरिथमेटिक दैट गिव्स यू अ जंप in terms of elements, not in jump in terms of absolute value. So pointer address +4 doesn't mean add 4 to that address, it's mean add 4 elements address to that particular address. Okay, so आज हम डिस्कस अभी थोड़ा और रिवाइज करेंगे pointers in 1 dimension arrays, arithmetic operators on pointers using pointer arithmetic. Pointer of 2 dimension arrays, I have not spent much time on 2 dimension array, so we will not be discussing this, but certainly we will be discussing 1, 2, 3 points today quickly. So given a pointer p plus minus n is a pointer to the value n element away. वही मैंने कहा था कि जब आप पॉइंटर के अंदर कुछ 4 ऐड करेंगे या 4 सब्ट्रैक्ट करेंगे या n ऐड करेंगे या n सब्ट्रैक्ट करेंगे, बेसिकली इट इज अ पॉइंटर टू द वैल्यू n एलिमेंट्स अवे. Plus n means forward n, forward 4 elements, or minus n means before 4 elements before. So in this example, A starts from here and P starts from here. A is the name of the array, which is the address of the array. When we say A plus 1, अब हम देखें, हम स्क्वायर ब्रैकेट्स यूज नहीं कर रहे, हम इसका एड्रेस यूज कर रहे हैं. पॉइंटर कॉन्स्टेंट्स, यहाँ पे भी +1 means +1 element, +2 means A plus 2 elements, A plus 3 elements, A plus 4 elements. But since we have initialized the pointer from the first element, so we can say +1 and -1. 1 element we can go back, 1 element we can go forward. And since we have started from here, so P plus 3 will be the last element. Since we start from here, therefore A plus 4 is the 4th element here. So this is the flexibility that we get whenever we load the address of an array into a pointer variable. In that case, we can even go backward, and we can go forward. So this is dereferencing, means we are using these pointers and we are using this pointer arithmetic. A plus n, what does it mean? The same thing that we have done with pointer variable, we can do that. A plus n multiply by मैंने कहा था 4 का मतलब 4 नहीं है, बल्कि 4 का मतलब है 4 elements. So size of 1 element, if it is integer, it could be 4, or it could be 2, or it could be 8. If it is float, it is 4. It is double, it is multiplied by 8. So it is A plus number of elements multiplied by the size of the element, and that gives you the actual address of the element where you should be there, where you should access that particular element. 3 examples. Character A of 3, integer B of 3, float C of 3. Okay, A is the name of the array, should point out to the address of the first element. A plus 1 is 101, A plus 2 is 102. Why it is 1 only? Because A is a character array where the size of the each element is 1 byte. But if B is an integer array, where suppose the size of the each element is 4 bytes. When we say B of 3, B of 0, 0, B of 1, add 4 because integer is of 4 bytes. In this example, B plus 2, 0 plus 2 bytes means not 2 bytes, 0 plus 2 elements. So it is not 102, but it is 100 plus 2 multiplied by the size, which is 4. 2 plus 4 is 8, so b plus 2 is basically 108, and it is the starting address. जिस तरह के यहाँ पर इन 4 बाइट का फर्स्ट बाइट का एड्रेस है, which is the starting address of the first byte of the array. Float. In this example, suppose in this particular example the float size is equal to 6 bytes. So c multiplied by 0 multiplied by 6 is 0, so first element starts from 0, second element 1 multiplied by c is 100, then 1 multiplied by 6 is 6, so 100 plus 6 is 6 here. C plus 2 element multiplied by 6, 12, so it is 112. So 3 examples: character array, integer array, and the float array. Good. Now we can access the array by simply just using the name of the array. What do we get when we say a of 0? It's mean we are interested a as a variable, or we are accessing its variable with the opposite index. Same thing we can do by using the name of the array as a address plus 0, and we can use it name of the array as a pointer constant, and we can use it like this. अब हम इसकी वैल्यू नहीं चेंज कर रहे, बल्कि इसमें ऑफसेट ऐड करके उस लोकेशन पे जा रहे हैं. नेम ऑफ द अरे +1, ए के कंटेंट अपडेट नहीं कर रहे, प्लस प्लस ए नहीं कर रहे, बल्कि हम कह रहे हैं कि इसको यूज करें एड्रेस, इसमें ऐड करें 1 एलिमेंट, यूज इन डायरेक्शन, सो इट विल पॉइंट आउट टू दी, जैसे ये a of 1 is equal to a plus 1 as a content, a plus 2 as a content, a plus 3 as a content, a plus 4 as a content. So a is the address of the first element, a plus 1 is the address of the next element. This is the 0 element, means the first element, 1 means the second element, 2 means the third, 3 means the fourth, and 4 means the fifth element. So we can use arrays, we have declared arrays, but we can use the power of the pointer. क्यों? क्योंकि name of the array is the address of the array. हमारे पास array का address जब आ गया, तो now it's up to us that whether we want to use it as an array or we want to use it as a pointer. Okay? Both are identical. ऊपर वाली example में देखें, यहाँ पे से 0, 1, 2, 3, 4 की जगह पर n use कर रही है. So a plus n steric means contents, और a of n contents. Next, मैंने आपसे कहा था कि we can check a pointer, the contents of a pointer, but only the null. हम सिर्फ null check कर सकते हैं pointers के साथ. Although we can put the address of one pointer into the other pointer variable, लेकिन जब कभी हमने check करना है तो suppose ptr is a pointer, so we can check if ptr is equal to null. What does it mean? If ptr equal null, or we can say if ptr is not equal to null, और दूसरी फॉर्म ये है if ptr is not equal to null or if ptr. इसका मतलब और इसका मतलब सेम है. हमने यहाँ पे कहा कि पॉइंटर इज इक्वल टू नल, यानी कि ptr में नल है. नॉट ptr का क्या मतलब है? ptr इज फॉल्स, और फॉल्स कब होता है? when it is 0, when it is null. So this statement, if ptr is equal to null or if it is not ptr, is the same test, क्योंकि 0 means null, not ptr का मतलब है not true. So if a ptr contains 0 mean it is not true, तो हम इसको ऐसे भी चेक कर सकते हैं और हम इसको ऐसे भी चेक कर सकते हैं. Similarly, if ptr is not equal to null, या आपका not equal to null होगा तो ptr true हो means true होगा. So if ptr means if it contains some valid address, if it is not 0, so this statement and this statement are the same. So pointers and relational operators, we can just test it with the help of null pointers, whether a pointer contains a null pointer or it is not a null pointer. Okay, suppose this is an array. psum is the smallest, it tracks the smallest value, and pwalk is a pointer that we move from 0 value to the next value. हमने एक array declare की and name of the array is ARY and P sum is we suppose that it is the smallest value, and then we would like to find out the smallest value. Since we have assumed that this is the smallest value, then P walk will start from the next, from this, then this, then this, then this. Okay, so after one initialization, array is equal to, so it contains the address of the array. So after first P sum is incremented, it is this one. If it is the smallest one, if it is the smallest one, then the P of walk should be equal to this one. Okay, since it is smallest one, therefore we have copied it back here. Second iteration, P walk goes to the next. Now P sum, initially P sum point out kara 32 ko. We assume that this is the smallest one, but if it is the 32 is the smallest one, then smallest P sum is this one, P walk is here. Next iteration mein P walk has moved down, but this is not smaller than 8, so it will move down here in the next iteration. Second iteration mein pointers ki ye position hai. P sum showing this one, P walk is here and P last is here. Next iteration, P small is here, P walk is here, P last is here. Fourth iteration, P small is here, P walk has reached to the P last. So here P last is equal to array plus size minus 1. We have defined array, that is the address that we have loaded into the P walk, or we'll see how we have initialized it. हमने P last को initialize किया here. P last is equal to array plus size, array size minus 1 means के जितने number of elements हैं -1, तो last का address हमने P last में इधर load किया. Remember, array structure contains 3 elements. First one is the initialization part, second one is the testing part, third one is the increment part. So we can have more than one initialization variables in the initialization part of the for statement. Here we say P sum is equal to array. We have declared a pointer variable P sum where we have loaded the address of the array. First element का address जो है वो हमने, because we assume कि first element contains the smallest value. Then we said P walk is equal to array plus 1. अब क्योंकि इसको हमने smallest assume किया, therefore we want that P walk should start from the next element. Okay, so initialization part has been completed up to this semicolon. Next, test. If P walk is less than or equal to last, we will run this algorithm until P walk reaches to the last and say that if the contents of P walk is less than the contents of P small, अगर P small के previous जो contents हैं उससे smaller contents मिलेंगे, तो हम इस pointer के अंदर उस variable का address load करवेंगे. वेरिएबल नहीं, P स्मॉल जब हमें इसको मिलेगा स्मॉलेस्ट, तो इसके अंदर हम P वॉक के अंदर जो भी एड्रेस होगा उसका स्मॉलेस्ट का वो उसके अंदर लोड करेंगे. सो दिस इज द एल्गोरिथम वेयर वी हैव मैनिपुलेटेड द अरे विद द हेल्प ऑफ 3 pointers. And here the same, define max, main, local declaration. We have declared an array that contain 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here is a P walk, here is a P end. So we'll see how we can manipulate this array with the help of these 2 pointers. In the next, we have said that P walk is equal to array. We have loaded the address of the array as a P walk. P end is equal to array plus P max size. Now P max में हमने already -1 किया. अगर आप ऊपर देखें हमने P max में 10 लोड किया है. So it is basically the 0 plus 10 is the address of the last element of the array. Second part, if P walk is less than P end, P walk जो है वो हमने यहाँ से 1 से start किया है. Has it reached to the last element? Until it reaches to the last element, we will keep on moving the pointer. And P walk plus plus, just like ordinary variables. But what will happen? Does it mean P walk plus plus means add 1 to the address of P walk? No, it will add 1 variable data type, size of the data type. So p walk plus plus means since it is array, कौन सी array थी हमारी? It was an integer array. So whenever we say plus plus, it means plus 4. So it means it will be the address of the next, then the address of the next, address of the next. So this plus plus does not add 1. So we are using these pointers p walk, p end and p walk to manipulate this array and to print out the contents of this element here. So p walk is equal to a, p end is equal to this one, p walk is less than p end, p plus plus, and then we print the contents. So it will print the content in the ascending order. Then is for loop में we do it reverse. Now p walk is equal to p end minus 1 means the address of this one, last element. p walk is greater than equal to array, अब आप reverse आ रहे हैं ऊपर until it reaches to the first element, okay, and p walk minus minus. So in the reverse order we can print the array also. That's it. So अच्छी examples थी that we have found in another book. So I decided to revise the concept using chapter number 10 of this particular book, and that is basically a structured programming approach. So whatever we have learned in the under the topic pointers, I have revised it also in this lecture. So dear students, we have learned concept of arrays, we have learned concept of pointers, then we have manipulated arrays and seen the overlapping concepts of arrays and pointers. Inshallah, next lecture में we will also try to find out overlapping concepts of arrays, pointers, and I will introduce another data structure which is called strings. और फिर हम array as a string और string as a pointer और इन तीनों की overlapping inshallah next lecture में सुनेंगे. Till then, खुदा हाफिज.